Myself, V.V.Gopala Rao, Assistant Professor, Department of Computer Applications, Aditya University. Today, we are going to discuss about a very important topic that is called Goback and ARQ related to MOSI channel, and which is actually the protocol we are finding out in the flow control and error control by the data link layer. So, before going to the details of that, we are expecting that the student will be able to know about the introduction of what actually this sliding window is, and similarly how the sequence numbers will be given to frames in the sliding window, and what actually the steps that are taken up by the Goback and ARQ. So here, first of all, let us start with the sliding window protocol. The sliding window is nothing but a buffer, you can call a memory area, where the frames are actually designated with some numbers, and the total number of frames also in the total window will be predetermined. For example, in this case of a sliding window, let us say that so you want to send certain frames, certain number of frames, but here the frames should be placed in the actual window, so that the window can carry the information from the sender to the receiver in number. That means the window can take the window can actually accommodate more than one frame here. So the actual problem that we have noticed in the stop and wait ARQ is now can be resolved in this case of Goback and ARQ procedure. Here we are, instead of a single frame, we are going to introduce more than one frame in this particular procedure of a sliding window. In this, more than one frame is actually being placed in the predetermined size of window. Remember that the window is nothing but a memory block where certain number of frames will be placed. How the numbering and all these things we are going to see in the actual in the process, and also what is the way of actually numbering the frames, that also we are going to see in the coming slides. Of course, the Goback is a protocol meant for the sliding window, and actually this Goback ARQ is a procedure which is basically follow the concept of sliding window procedure, and of course which is actually been seen in the data link layer for the sake of flow control and error control. But here in this case of sliding window, let us see that a frame is there here, and let us say you have some number of frames called 7. Let us say you have total number of frames which are actually 7. Now we are going to fix, or we are actually decided that the frame should not consist of the 4 frames. The window should not have more than 4 frames. Then actually these this area can be, the memory area can be numbered like this: 0, 1, 2, 3. Again you start with another 0, 1, 2, like that. It will be carried out like that. So even though you have 7 frames, but because of the frame numbers which are actually following the actual some concept called of modular arithmetic, so we are numbering the frames like 0, 1, 2, 3, again 0, 1, 2, and so on. So this is based on the modular arithmetic concept, that also we are going to see in the coming slides. Of course, here I am going to show that what actually the sliding window means. Sliding window means it is nothing but a memory block where frames are placed. Here more than one frame can be seen in this to introduce the concept of pipelining. So this is not there in the actual stop and wait ARQ. Single frames are actually placed in the stop and wait ARQ. So to avoid that problem of the actual non-pipelining, so we are introducing this kind of pipelining in this by introducing more than one frame in this window. So now why it is called as sliding window? Because based on the transaction that is taken up in the overall course, so the window may move, or the frames that are received can be removed from the buffer, and the frames that are expected by the receiver will be added in this particular scenario. That is why this is called as a sliding window. So generally we won't say that the window will slide, but the thing is the process of removing the process of adding of frames based on the request is taken up here. So that is why this process is called as a sliding window as a whole. Now here one more important point is mentioned here, which is underlined. Based on the acknowledgement from the receiver, retransmission of frames can be done from the nth frame onwards. Actually, go back n means here n is nothing but the frame that is interested by the receiver. From that frame onwards, he is interested to get the all the frames which are from the 10th frame onwards. That is actually the meaning of go back n ARQ. I already told you that this is a request. It is a request kind of a procedure. Unless there is a request from the receiver, sender will not take any decision, because receiver is requesting from nth frame onwards. He is actually interested to get the retransmission, so he is putting that request in front of the sender. So based on the nth number, so the sender is able to retransmit all the frames from that number onwards, nth frame onwards. So that is why this particular sliding window protocol, in that especially go back and ARQ, is a very interesting procedure by which you can able to control the flow and also the error control in this. So sliding window, of course, is an abstract concept that defines the range of sequence numbers that is in concern with the sender and receiver, that we are going to see in the actual scenario. The sequence numbers are playing a very important role in this. So based on the sequence numbers only, so the sender can able to represent the actual frames that are actually put in the window, and also receiver also can able to represent what type of or what frame is received properly, and from which frame he is interested, so that can be identified in this particular procedure based on the sequence number. That also we are going to see in the following slide. Okay, now suppose if you see that if the header of the frame allows m bits from the sequence number, the sequence numbers can range from 0 to 2 to the power of m minus 1. That means what? Suppose I am going to send some frames. Okay, then my header is limited to only m bits. My header, that means along with the frame, some header is also there which represents the frame number here. So actual frame contains the data, and before that, so every frame will be numbered. So that is why that is called as the header. You can refer here. So in that header you can able to understand what actually the frame number is. Suppose the frame allows m bits. That means suppose the header is allowing m bits. For example, m is nothing but 4. Let us imagine that you are allowing 4 bits to be accommodated in the header, let us say. Then what actually the frame numbers can be standing here. So because m is 4, so according to the principle, so the sequence numbers can range between 0 to 2 to the power of 4 minus 1. 2 to the power of 4 minus 1. That means if you simplify this, so the starting frame can be 0 and the next frame can end up with the final number that is called 2 to the power of 4, means it is 16, and less than 1 means 15. That means the numbers can be, the sequence numbers can, the frame numbers can be between 0 to 15. So that is why in the example also it is shown the frame numbers in that way only. 0, 1, 2, 3, 4 up to 15 is there. Again 0 is appearing because the m value is 4. You cannot go with 16, 17, 18 because when m value is 4, the maximum number you can assign to the frame is only 15. So that from 0 onwards. So that is why 0 to 15 and again it is starting with 0 only, and it again goes to 15. Again after that it starts with 0, like that the process can take up here. So that is the reason why the m number of bits is playing a very vital role with respect to the header of the frame. So every frame will be headed by some number, and that number is nothing but the actual frame number which is also called the sequence number of the frame. So what actually the numbering concept is, following the arithmetic is the sequence numbers are basically following the arithmetic called as modulo 2 to the power of m. You divide the actual frame number. Suppose you have 20 frames are there, and you divide that with the 2 to the power of m, whatever the remainder that you are getting, so that can be assigned to the actual frame in the scenario here. So I hope that this particular the role of m, and based on that the sequence numbers, how it is actually happening, I think you are clear. Let us take one more example. Let us say you are allowed only 3 bits, accommodate in the header. Let us say m is equal to 3. Then what is the frame number, sequence numbers you can go up? So here from 0 to 2 to the power of 3 minus 1, that means 0 to 7. These are the valid sequence numbers you can actually assign onto the frames in this case. So this is the way how the sequence numbers in the sliding window is possible. And the same thing is shown here. There is a sliding window. So here with respect to the m is equal to 4, the frame numbers are actually shown on the screen. So here the red colored frames are there, which are actually in the transition, whereas the white colored frames are there in the waiting stage. So that the frame is there, total window is actually 0 to 15, but because of the actual transaction to be conducted in a smooth manner, the sender window size should be less than 2 to the power of the size of this sender window should be 2 to the power of m minus 1 here in this case. So here that is why the sender window is showing that the outstanding frames and also the next frames to send is totally shown in this case. Of course, you can be very clear about once you actually start the actual process. From there, you can understand how the process can be carried out in the sliding window concept. So this is actual the Goback and ARQ. And here you can be very clear about what actually the sliding window is playing a very important role, and how the flow can be controlled and how the error can be controlled, you can be very familiar. So now in this case, if you start from the leftmost side, that is called start timer and stop timer. In between that there is a timeout to restart. So already I told you that this is the actual timeline which says about when it is to be started and when it is to be ended, and suppose if timeout takes place, then what is to be taken up, what is to be done. That is actually shown in this case of Goback and ARQ. So here let us start with the total window. This is actually the starting window is with 0 to 6, and of course we start with 0 to 6 frames already in the transmission, let us say. So let us say that the window is starting with some number of frames. Why 7 is not actually taken up here? Because I am saying that the window is actually taking the initial frames which are actually numbered as 0 to 6. So imagine that these frames are actually placed at a stretch in the actual channel, because it is a noisy channel, and because we are also recommending for pipelining, so more than one frame can be accommodated in this. So imagine that frame 0 to frame 6 are actually put it in the channel. So, and imagine that the frame 0 is in the transmission, and of course frame 0 is received by the receiver properly. And then after that he is acknowledging, because sender should not take any action without any acknowledgement. So sender has to take an action based on the acknowledgement made by the receiver. Once the receiver is saying that ACK1, it says two important factors. One is called as whatever the frame that is numbered in this ACK, prior to that all the frames are received properly, and which is expecting that ACK1 says that from the number 1 frame onwards, whatever the frames which can fit in the sliding window are expected by the receiver. That means because 0 is received successfully by the the receiver, and which is saying that ACK1 means so 0 frame is successful and frame number 1 is expected. That means frame number 1 onwards. Frame number 1 onwards, it is expecting all the the set of frames which actually fit in the sliding window. So that many number of frames it is expecting by the receiver. So that is the meaning of ACK1 here. So based on that, because it is received by the receiver, so based on that, the sender can able to start its job by dropping frame number 0, because it is already received properly by the actual receiver. So it can drop frame number 0, and frame number 1 onwards, it is adding the rightmost frame, that is called 7. It is 7 is joined and 0 is dropped here. So that is why this is called as a sliding window. So frames can be dropped, frames can be added as far as the request is concerned. So that is why this frame number 0 is dropped and frame number 7 is added, so that the total number of frames in the window is again as per predetermined number here. So that is why this now 1 to 7 are actually in the transmission. Imagine that frame number 1 is there in the actual the transmission, but due to some reasons it is lost. But remember that because we are in pipelining, that means only frame number 1 is not there. So all the remaining frames are also traveling in the channel, so that the frame number 2 is also there, 3 is there, and like that all the frames are actually traveling from the sender to the receiver. But after some time, the receiver is saying that ACK2, that means frame number 2 is in the transmission, frame number 3 is also in the transmission, and frame number 1 is recent, because the sender is not actually getting the information from the receiver. So what actually happening is, the sender is actually again sending frame number 1, because the ACK2 is actually mentioned by the receiver. ACK2 says that up to frame number 1 it is received properly, and it is expecting the frame number 2 onwards it is expecting the remaining frames, so that the frame number 2 is actually taken up here in this case. And of course, in this total scenario, once again, if you see the frame number 1 is lost, and frame number 2 is in the transmission, and also frame number 3 is also there. And here, after taking up the frame number 3, why it actually sent again frame number 1? Because the no response is there received by the sender from the receiver. So it expects that after timeout, so no response is there from the receiver. So the sender expects that nothing is received by the receiver properly. Again, it is retransmitting frame number 1 and frame number 2 and frame number 3 and so on. All the frames again retransmitted, because no response is there from the receiver, because the frame 1 is lost, so receiver is keep quiet, and automatically because the timeout is also happening, so automatically the sender can able to expect that nothing is received by the receiver, so it retransmit all the frames starting from frame 2, 3 and so on. Okay, so now in this case, after some time, the sender received ACK2. Means what? So ACK2 reveals two important things. Frame number 1 is received properly, and from 2 onwards, it is expecting the repetition of the frames. So based on that, what is happening is, you see that once after getting this ACK2, then the sender can send the frames which are from frame number 2 onwards. That means frame number 2, frame number 3 and so on, whatever the frames that are there in the window. So all the frames it is going to send because of ACK2. And because of ACK3, you can say that up to frame number 2 it is received properly, and it is expecting the frames from frame number 3 onwards. So like that, so the frames can be resent again and again based on the request that is made by the receiver. So here, that is why this process is called as Goback NARQ. Here the N stands for the nth frame onwards. Whatever the frames that are requested by the receiver will be retransmitted only on request. So that is why this is automatically being carried out by the process, and that is why it is called as automatic repeat request, based on the nth frame that is actually quoted in the form of acknowledgement by the receiver. And from that onwards, again the process will be carried out, go backs to that particular frame which is expected by the receiver, and from that frame onwards again the retransmission will be done. So that is why you can able to say that the frames that are actually lost, the frames that are actually duplicated, the frames that are not actually received properly by the receiver can be controlled in this case of the retransmission, so that the receiver can able to confirm, yes, whatever the data frames that are there in the total transmission can be received properly. Finally it is a successful transaction, it can able to say that. And that is why this particular go back and is a process of controlling the flow, and as well as controlling the errors that are actually occurred in the actual transmission. The errors may be of frame lost, or the errors may be frames may be corrupted, or the errors may be like this, frames may be duplicated, but all these things can be clearly carried out in this case of the go back and ARQ. Of course, in this go back and ARQ, efficiency is comparatively good with if you compare with the stop and wait ARQ. In that pipelining is not there, so that it is not efficient. But whereas in this case of sliding window, more than one frame can be put it in the transmission, so that it can be referred as a pipelining concept is introduced in this. Because of that, sliding window is comparatively efficient process, and especially the go back and ARQ, the frames can be repeated based on the number that is suggested by the receiver. So I hope that by this the student is able to know about what actually the sliding window, and how the sequence numbers are designated to the frames, and what actually the process of go back and ARQ, and how it can reflect the flow control and error control successfully. Thank you.